Hi, hello, namaste. Welcome to Emuna's Learning Point. In this video, we are going to learn about fundamental theorem of arithmetic. Before going into the theorem, let's know about the prime number and the composite number. Prime number is nothing but a number which is divisible by itself and 1 is called a prime number. And a composite number can have itself and 1 as its factors and also the other numbers. Example, if we consider the 2 will have 2 and 1 as its factors. Other than 2 and 1, it does not have any other factors. When we consider 6, the 6 will have 2, 3, 6 and 1 as the factors. Hence, we can say that 6 is a composite number. In this way, we can differ the composite number and a prime number. So, let us go into the topic. The topic is Fundamental Theorem of Arithmetic. The Fundamental Theorem of Arithmetic states that every composite number can be expressed, or else we can also say that it can be factorized as a product of primes. And this factorization is unique apart from the order in which the prime factor occurs. So this is the statement. Now let us go into the every line we have read. So every composite number can be expressed, means for example if we consider the 6 which is a composite number. Now this composite number can be expressed as 2 into 3. This composite number can be expressed as 2 into 3. How to express a given composite number like this? In my previous video, I have explained to you about the prime factorization. So, using the prime factorization, we can express the given composite number as the product of primes, or else they can be prime factorized as the product of primes. And we can also say that this factorization must be unique. If 6 can be expressed as 2 into 3, then no other number in the real numbers can be expressed the same. Every composite number will have the different expression of their particular product of primes. And next point is apart from the order in which the prime factor occurs. So it must be unique without regarding their particular order. For example, we can write 6 as 3 into 2 also. So we should not consider in which order we are going to write the prime factors we have got from that particular prime factorization. So, in this way, we can define the fundamental theorem of arithmetic. Once again, I am going to say what a fundamental theorem of arithmetic using the 163800 prime factorization we have done in the previous video. In the previous video, I have explained you how I have done the prime factorization for 163800. After doing the prime factorization, I have got the prime factors like this: 2 into 2 into 2, 3 into 3, 5 into 5, into 7 into 13. So, after factorizing, we should have only the prime factors because we are pronouncing it as the prime factorization. Hence, we should only have the prime factors after the prime factorization. After the completion of that, we have got 2 cube into 3 square into 5 square into 7 into 13. So in this way, we can express the composite number as the product of primes. And after this topic, I am going to explain you about the HCM and the HCF and the LCM of 12 and 18. So for 12, Let us prime factorize the 12. When we prime factorize the 12, we will get the value 2 into 2 into 3. After that, if we write that, we can write them as 2 square into 3 power 1. And 18 can be prime factorized as 2 into 3 into 3. So, we can write it as 2 power 1 into 3 square. Now, we are doing the HCF for 12, 18. So, HCF means nothing but highest common factor. So, the highest common factor is nothing but the HCF of 12, 18. In order to obtain the highest common factor, we have to obtain the minimum value from this particular 2 square and 2 power 1 obtained after the prime factorization of 12 and 18. When we compare 2 square and 2 power 1, we can observe that here the minimum value is 2 power 1. So we are writing the 2 power 1 here. And when we prime factorize 12, we will also get the 3 powers. That is 3 power 1 and 3 square. In 3 power 1 and 3 square, the minimum value is going to be 3 power 1. So we are writing the 3 power 1 here. And after that, we have to multiply both the values. When we multiply, we will get a value called 6. So in this way, we are going to perform the HCF. And after that, LCM. Here we have took the minimum value, and in the LCM we are going to take the higher value or the maximum value. And here the maximum value is 2 square and here the maximum value is 3 square. So when we multiply 2 square and 3 square, we are getting the value called 36. So the product of the greatest powers of each prime factors in the numbers is called LCM, and LCM is nothing but least common multiple. So in this way, we are going to perform the HCF and the LCM. So I will be coming out with another video discussing about the next topic.